Okay, what we're gonna look at is absolute value. And first, I just want to remind you of how to do just the basics of absolute value. If I say, what's the absolute value of 3, no longer that answer, what is it? 3. And if I say, what's the absolute value of -3, that answer is also 3. So absolute values are never negative numbers. The absolute value of a number is never a negative number. There's a more formal definition for absolute value that you'll do in pre-calculus. But this will be pretty much good enough for what we're going to work with right now. The one other one that sometimes people forget about is this one. The absolute value of 0 is 0. Okay, not a negative. But some people say absolute values are always positive. That's not quite true. Absolute values are never negative, is actually what's true, but they can be equal to 0. Okay? The other thing I want you to be able to do is the basic order of operations with absolute value, understanding what you have to do first, and second, what order do you do things in. They fall into order of operations at the same place as parentheses. So they aren't parentheses, but they fall into order of operations at that same spot. So the first thing you would do here is what's inside the absolute value. That would be the absolute value of -3. All right? And then you have to do the absolute value itself before you can do anything that's outside the absolute value. Does that make sense? Yes? So what's the absolute value of -3? So you do 2 plus 3, which is 5. Okay? If we thought of them as parentheses, just momentarily, and we're thinking of the order of operations here, we would do what's inside the absolute value box. What's the absolute value of 4? I mean, what's 4 minus 2? What's the absolute value of 2? And then you multiply it by -2. Since that was outside the absolute value, it doesn't become, oh, why did I change it 3 to 2? Okay, sorry, Michael. Okay. Then you multiply it by that -3, which is outside of the absolute value, so it doesn't become positive. Y'all see? It's not being affected by the absolute value. So your final answer here is -6. The single biggest mistake that I see students make with absolute value is that they think they can use distributive property just like as if they were parentheses. And while that will sometimes get you a right answer, it doesn't always get you a right answer. And so I say, I just don't use distributive property with absolute value. Don't use distributive property. It only works sometimes, and I guess if you worked it enough, you can figure out when it works and when it doesn't work, but you're really not supposed to do it. Okay, and I usually will catch it when you do try to do distributive property. Okay? Alright, now pick up the calculators. And we're going to work these 2 problems, and you can still see them because they're not disappear from the board. These 2 problems on your calculator. Yes. We recorded that too. Okay. All right. So I don't want to be on line first. Go to your home screen on your calculator, and we're going to type in that absolute value expression. The absolute value bars are here. Push the back button. Go over, push the arrow key to the right, and there it is, number 1. That's where absolute value is. Did I say? So when you need it, that's when we'll go get it. All right? You want to type in the first problem, number 4, that I had up on the examples, would be 2 plus, and then you would go to math, press the right arrow key, and press the number 1, and your absolute value bars will show up. If somebody has a little bit older calculator, I've usually got a few people who've got their sisters or brothers' calculators, and it doesn't have those bars on it, then it will look like this. And it'll have a parentheses right there. Does anybody in here have that? Okay, so then you would type what's inside those parentheses, 5 minus 8, and press the right arrow key again to come out of the absolute value bars. For someone whose calculator has tabs, you type 5 minus 8 and you close parentheses to show the end of the absolute value bar. This is the old way they did it, and they upgraded it, and now it looks nice. Okay? So I know there's somebody in my board that has that. Alright, and then you got it all typed in. All you do is hit enter, and the answer is, of course, 5. Okay? Alright, so let's do problem number 5. Is -3 times, and then you have to get the absolute value bar up, math, right arrow key, number 1. There's nothing intuitive about that. There's nothing that says, oh, I know where it is, it's math, right arrow key, number 1. That makes perfect sense. It doesn't make any sense at all. You just have to remember where it is, okay? Alright, and then type it in 4 minus 2. And pop out of the absolute value to the outside, and hit enter, and again it will be -6. I'm going to write this up just one more time, because I know there's that person that has this. It's going to look like this, and you have to close your parentheses. Right? Easy enough? Okay. The next thing we're going to do is we're going to look at what graphs look like with absolute values in them. And I don't know if any of y'all did absolute value graphs last year in Algebra 1. Sometimes teachers will do it. It is not traditionally part of the course. Some people just like doing it. Okay, so we're going to go to y equals, and we're just going to look at this graph. Yeah. Right arrow key, number 1, absolute value. And inside the graph, we're going to type, inside the absolute value, we're going to type x plus 2. And outside the absolute value, we're going to type minus 5. So it's the absolute value of x plus 2. And then outside the absolute value is minus 5. So we got it typed in? Yes? We're going to do a zoom 6, so you know for your calculator what you're doing. And that is what that graph looks like. It's shaped like a V. Did anybody ever see this last year? Okay, well then good. You're getting reminded of it, okay? It's shaped like a V. Your job is to get this equation on your paper and this sketch on your paper so that it looks pretty much like this. So we got it? It will be I guess this is problem number 1. Y equals the absolute value of x plus 2 minus 5. Okay? Nice little sketch. It doesn't have to be blue. It looks kind of like that, yes? If you picture it on your graph, it looks almost like a check mark instead of a V, but that's just because it's over this way. If we made this go further out, this would keep going up, and it would be very symmetric. Same thing on one side as the other side. Is that good? All right, this little point down here has got a name. This point is called the vertex. It's called the vertex, and that's the point that we're going to label on this graph. Next week we're going to label other things on it, but for this assignment we're only going to label the vertex. So I'm going to show you how to get that on your calculator. And there's a series of buttons you have to push. And I suggest that you listen the first time and push the buttons and stay with me, and then the second time you write them in. Okay? Alright, you're going to use second, and then you're pushing this trace button. So when you push second trace, you're actually pushing calc, which is where we calculate things. Okay? And we've already used second calc to find the intersection. We use it for number 5. Yes? Okay. We're now going to use it to find that little point. That picture looks like this. We want this little point at the bottom of that picture. Which one of these things suggests to you something at the bottom? Everybody. Minimum. We are going to choose minimum for this. So we're going to pick number 3. Type 3. And it takes you back to the graph. And what happens is you have this little flashing cursor here, right there, little bug, all right? And down here at the bottom, you have this question: what is the left bound? The calculator is saying, where do you want me to look? It doesn't just know where the minimum is, you have to get it sort of targeted in. And we need to get to the left of the minimum. Here's the minimum, and right now we are right here. Are we to the left of it? No, we are right now to the right of it. So you need to press the left arrow key. Watch the little, actually looks like a flower. Watch it until it gets over to the left. How far over? I don't care, just as long as it's left. Did I see? Okay. When you are to the left of your point of interest, you're going to hit enter. And it gives you this lovely little boundary line. The calculator is only going to look to the over to that side. Now it has changed the question. The question no longer says left bound, it says right bound. And you're going to move to the right. I suggest you do this, and then I'll give you a chance to write it down in a minute. Okay? Go to the right of this and hit enter again. And you're telling the calculator, I want you simply to look between these two lines and find me the smallest thing that's there. Yes?
I think that
If you don't get these questions, you pushed something wrong or you haven't pushed the right button. Okay, let's do this one more time. Okay, and look, the question has changed. What's the question now say? Guess. That means get kind of close to it and hit enter. Okay, so get kind of close to it. I'm going to push my left arrow key again until I'm kind of close, and I'm going to hit enter. Okay, now we are not all necessarily going to get exactly the same thing because the calculator is estimating here. Okay, listen. Sometimes we will get slightly different answers. What I need you to understand about this weird looking answer, this 1.9999999, that really is not 1.9999999. It really is 2. Okay? Sometimes you will get 2.0000004. That's not 2.00004, it really is 2. This is the calculator guessing. And guessing again until it gets what it says is, okay, close enough, I'm done. And it just didn't quite get there. Now raise your hand if anybody got this 1.99999. Did anybody get 2.001? Did anybody get 2? Okay, yay, surprise. Okay. She didn't do anything better or different. It just the calculator just got there for her before it gave up. For the rest of us, it just didn't quite get there. Okay? So this number is not really negative 1.9999. This number really is negative 2. And what does that make this number over here for? Negative 5. Who got the same thing I did? Negative 4.1. Who got negative 5.001? Somebody get 5 there? Yay. Okay, so it is. Okay? So I'm glad that happened up on the board so that you can see it. It's not always 9s. Sometimes these last few numbers will be 3, 4, 6. Okay? The calculator, y'all ever cleaned up your room for your parents? And you got to a certain point, you learned that it really wasn't done, right? But it was good enough, and you knew it would get by. That's kind of what's going on here. Okay, so we're going to go back to our picture that we sketched, and we're going to write the vertex in, which was negative 2, negative 5. We're going to label the vertex. Everybody see how that works? Any questions about that? Okay, now I'm going to let you write down all the steps of that in a few minutes, but we've got one other thing that we're going to do about absolute value graph. One of the big things you're going to notice about an absolute value graph is it doesn't just go up and it doesn't just go down. It does both. It starts out by decreasing. Y decreases. Then Y is increasing. And the place that changes is at the vertex. Decreases and then increases. So what we're going to write down is a description of where it decreases and where it increases. Okay? And it's really pretty simple. This is the way you're going to write it. Y is decreasing. You're going to say the word when. X is to the left of the vertex. Y is decreasing, and the X values are to the left of the vertex. All of these points right here have X's that are left of the vertex. X is less than negative 2. Did I see? Okay, and then you're going to write Y is decreasing when X is to the right of the vertex. That's all of these points here. Everything to the right of the negative 2. You notice that we're picking up this number, the X number, not the Y. Okay, see? That's the process we're going to use for each one. All right? Now we're going to work the second problem, and as we work through this problem, I want you to take down all the notes that you think that you will need in order to do this on your own. Okay? And we will then work the third problem, and you will look at your notes and see if they were good enough. Okay? All right, second problem. Looks like this. There's our equation. Y is equal to 6 minus the absolute value of X minus 3. I don't need y'all trying to figure out why your graph looks like it looks. We're going to get into that later. I just need you to get comfortable with the calculator, with finding the vertex, and with this increasing and decreasing part. That's step 1. Okay, so go to your calculator. Y equals, fill it out. So I'm going to erase all this stuff. Type it in. After you type it in, look at it and make sure you type it in right. It's so easy to type a negative instead of a minus, okay, or plus instead of a minus. You have it typed in right. I always like to start with resume 6, just in case I've changed the window. Also a V, but not quite the same as the last one, yes? How's it different? It's upside down, or the other one's upside down. One of them's upside down. They're going in different directions. Okay, everybody got the same picture? Okay, so we have to find the vertex. We need to find the vertex here. We gotta sketch the graph and then we gotta find the vertex. I'm gonna let y'all sketch it, so I don't have to switch back and forth. To find the vertex. You're all ready to find the vertex? Like, as we're finding this vertex, I want you to make sure you've got your notes written down about how to find this vertex. Okay? Did anybody do parabolas last year? Yes, they have a vertex also. They're curvy, and we're going to use it again when we come back to parabolas. We do the same process. Okay, we ready? Everybody got sketched? Okay, so to find the vertex, it's second trace. I always say second calc when I say that. When I write it, I say second calc. Okay, this time our picture looks like this. So I don't want to look for the minimum. I want to look for the maximum. So in your notes, you need to say, if it's a V with the point at the bottom, I'm looking for minimum. If it's a V with the point at the top, I'm looking for a maximum. Make sure you do that in your notes. Okay? And you type either 3 or 4, depending on which one you're looking for. Okay? Then you must move your cursor to the left side. Now, last time we actually had to move it. This time, do we need to move it, or is it already on the left side? Okay. Mine's already on the left side, yes? If you make sure the cursor's on the left side of your vertex and hit enter, and then you need to move your cursor to the right side. How far to the right? I don't care. Just somewhere to the right, and hit enter again. You might notice that this time I've given it a much broader place to look than I did last time. I made it a little bit closer. And then you have to put it kind of close to what you want. Get kind of close. Remember to use your left and right arrow keys for this, not the up and down. And hit enter for a first time. And mine did it again. Okay? So here's what I was talking about. See how it didn't end with 9s at the end of this? That doesn't matter. 2.9999968. The calculator really means that the answer is 3. And it did it at the end of this one. I'm really glad this happened because this is going to happen to y'all. That way you've seen it happen. Okay? And this answer is y equals 6. It got exactly 3 and 6. Nobody? Okay, they really will do it sometimes, I promise you. Okay? I think probably if we had gotten like really close to it with the left and the right, it might have done a better job. Okay? Okay, so you're going to look at your sketch now. And I'm going to get my sketch up here. You're going to label the vertex like that. Okay? And then you're going to write the increasing and decreasing segments. So what is it doing first? As we first started about this, is it increasing or decreasing? Increasing. So look at that from first. Why is it increasing? You can put INCR. That stands for increasing. That's perfectly acceptable. You're going to write the word twin. X is. And for this section, for this part of it, all of these are to the left of the vertex. Yes? So that means X is less than the X coordinate, 3. And then you're going to say Y is decreasing when X is, that is this part over here, which is to the right, X is 32. Not too hard, right? Most of the new buttons switch, okay? They're going to be Ds. Not all absolute value graphs are Vs. There are some other ones we'll be putting up later on, but a lot of them are. And I don't remember, that's a pretty nice stuff. It's nice for your math because they can't. We're going to try this one. And I'm just going to give you a little warning, something weird is going to happen. See how you do it. Everybody else getting a little bit warm? You know? Out there. Make sure you come out of that absolute value thing before you type them on Excel. One of the most common mistakes is not really coming out like that. Okay, I always get dim selects just to make sure. And go ahead. You can't see all of it, right? But you know, we're all really pretty smart. Where's the rest of this graph? Down, yes? The vertex is down, so we need to go to the window and change the window. It doesn't look like it's too far down either. Which one of these numbers do we change? Lyman. Now on the homework, you might have to change Lymax, or you might have to change one of the X's. Okay, so make sure you get on the right one, Lyman. And I don't think I think negative 20 will work. I actually think negative 15 might work. I'm not going to do 20. And remember, it doesn't matter what you pick. As long as you pick something that works, and then you label it when you sketch your graph so that I know what you did. Yes? So when you do your little sketch, like this, you make sure you put that negative 20 down at the bottom of that graph, so that or negative 15, so that other people know what you've done. Okay? Draw your sketch. And then find your vertex. Is it a minimum or a maximum? Minimum. I'm going to try to get a little close, not going very far, but to get that goes into a little bit better. Okay, every once in a while, we can all get there. The computer, the smartboard has stopped accepting my. Okay. People on watching the video, I'm sorry, the smartboard has stopped accepting what I pressed. But if you press this, press the enter button several times, and one time it also comes down and give you the final answer. She say yes anymore, and the answer should be 0, 12. Did anybody get this weird looking thing for X? Like 2.8604, and then there's an E at the end of it. Did anybody get this? 2 people did. Everybody needs to look at this and write it down. Okay? If you get, I don't care what this number is right here. It makes no difference. Whatever this is, positive, negative, it doesn't matter. When you get this at the end, that is scientific notation. You all done scientific notation before? Okay, the scientific notation to the negative 10 means that number, you write that number down, whatever, and the decimal was here, and now move it over 10 places. Okay, so you've got a whole bunch of zeros in front of us. This is the calculator trying to get to 0 and not quite getting there. Okay, so you need to put this down as an example. If you get something like this, then it means 0. Okay, it's this E with negative 10, or it might say E negative 12. It might say E negative 8, but it's going to be an E and a negative number up the end. It's really trying to say 0. Everybody got that? Okay. You've got your sketch drawn. Sketch drawn. This is up a little bit. I have negative 20. It looks kind of like this, right? And your vertex is 0, negative 12. And the last thing is to write y is increasing when x X is something and Y is decreasing when X is something different. I don't care which order you put them in. Some people like to put them left to right. Some people like to always put increasing and put decreasing. Okay, that is your choice. Okay. If I were going left to right, the first thing it's doing is what? It's doing what, section? Decreasing. So decreasing, I'll do this one, is to the left of the vertex. And then increasing is to the right of the vertex. Again, notice that this is the x coordinate of the vertex. Is everybody good? You gonna handle this? Okay, except for those weird numbers in the calculator. So, okay, we're all done, and we have a worksheet to do. It goes along.